'Cause I'm the data guy, making bytes fly high, diving deep into the data, reaching for the sky, from ETLs to data lakes and pipelines that don't break. Tune in, hang on, and let's make data great. Hey y'all, Data Guy here. And so today I am back with one of my more kind of general, intro to data topics. And something that I honestly didn't really know for the longest time until I made this video. And that's why I had to look this up for work. And I was like, this is kind of annoying to just like have the differences laid out. But now I want to pass that knowledge all along to you in an explainer video on what a database does versus a data warehouse versus a data lake. So, you might know the general concepts. All of these hold data and, structure, their data storage, and the general way you interact with them is the same, but they're actually used for very, very different purposes. And so I'm going to go into kind of an explainer of, what each of those purposes are, and some of the advantages, disadvantages for particular systems. So, where you're going to want to use one for, long-term cold storage versus, one that has really efficient I/O in-out operations. I'm going to break all of that down for you today. So we're going to go step by step, go to database, data warehouse, data lake, and then we'll come back and wrap it all up with a kind of a comparison chart between the three. So without further ado, let's get into it. So what is a database? At its core level, it's structured data storage. It has a predefined schema. So you define, hey, this is how data is ingested into this database. If your data doesn't fit that schema, it's going to break and it just won't be ingested. And this is optimized for transactional processing. When you expect, hey, this is, and transactional processing is exactly like it sounds like. Imagine you're a shop that is processing purchases. You know that it's always going to be a dollar format. It's going to have a product ID. And while, those are going to change, the format of that data is going to be the same. And it's constantly, going in independently. So you have, you're reading in a single purchase at a time, maybe. And this could be something like, for the back end of an e-commerce site you have, banks use setups like this, inventory management, making sure, hey, when someone buys this, it adjusts my current inventory. And the advantage of a, basic database is that it has fast read-write operations. And it is designed to be, ACID. And what that means is, I'm not talking about the drug, it is atomicity, consistency, isolation, and durability. So databases are all about saying, hey, I have this firm structure for my data. I expect it to be in this way. If there's some kind of data that isn't outside the structure, I want to know about it. This database needs to never go offline. It needs to, have fail-safes because it's powering the core transaction part of my business. A lot of times these are powering customer-facing operations. So some of the downsides of this, because it's so good at I/O, because it's good at processing kind of small amounts of operations constantly, is it's not really ideal for massive volumes of data, and it's limited to that structured data. So you can't get unstructured data of varying types, and so what a lot of times you'll do is you'll have a database that is kind of your first line of defense, collecting that information. It's batching it, if you will. So, your purchases go into your database, and then, maybe every week you collect all of that information that's in that database, move it out, and bring it into, your cold data storage, into a data warehouse, which we'll talk about next, for the actual storage of it at scale. And then that way you can clean out your, that database and then, reset it. And then once it gets full again, clean it out, bring it into long-term storage, so it doesn't start to slow down, because as your data size grows, the time it takes for your queries to actually run on that data become for longer and longer, because if you're saying, hey, select all or search all, it now has to search more data, which just is, it's something you have to deal with at scale. So that's kind of a database. So that's why I wanted to show you this graph, because you have maybe different aspects of that database that are performing. Some are collecting your customers, some are collecting purchase information. It's where you can query and kind of manage that data. And that data might be coming in from applications, from, users, or from even other databases. So now I've kind of gone through regular database. Let's move on to data warehouses. So with your data warehouse, what is a data warehouse really? It is optimized for analytical processing, for being able to perform your analytics on massive amounts of data. So, as your business, collects all that data, you want to start generating insights in it, maybe train ML models, figure out how to improve, upon your existing processes. So that is what data warehouses are for where, you've
brought your data in from those smaller databases, which you can imagine are these data sources here on the left, then that data is transformed. It's gone from just kind of its raw intake method format into whatever format you've decided is best for your particular querying use cases, and that's going to differ for really everyone. And then once it's in the data warehouse, your data is going to be, it should be structured, it's processed, it's undergone some transformation. So your data warehouse has data that is just ready to be used by your kind of downstream users, which are, business intelligence units. It's kind of like a CIA intelligence unit, but reporting, doing reporting analytics, creating visualizations, understanding, everything about your business and your data processes. And so data warehouses store that massage data, which is defined, typically by a data pipeline. It's pulling from those other data sources before it's brought into the data warehouse. So that way, it doesn't need to undergo additional transformation, so you can actually get insights from it. So you can do things like predictive analytics. And so the advantages, so it is kind of like I discussed, it supports a lot of complex queries, aggregations. It's able to consolidate data from a lot of different sources. These, will typically be massive, and they're, collecting data from across your company. And some of the limitations of it are, because it gets so large, even though it is optimized, it's not good for running real-time data processing within your data warehouse. Although Snowflake, that's kind of their pitch is, hey, you can have a data warehouse where you can run all of these kind of transformations within. So instead of having to do transformations before you get in the data warehouse, you can do them within Snowflake at a really low cost, because it does require ETL processes to create a true data warehouse, because your data needs to fit some level of standard. And so the old ways, you're not going to do real-time processing with your data warehouse, but now that is a little bit flexible. And so now we've kind of talked about a data warehouse, let's talk about our final one, which is a data lake, which is the one that's a little bit more elusive to describe. And so finally we have our data lake. So some of the characteristics of a data lake, and really the key one, is that data lake is really just a place to store raw data. So you just dump data into your data lake. It has a schema on read approach, which means it'll just intuit kind of whatever format the data is in. It'll store it in that format and kind of create a corresponding schema. So it's really kind of the opposite of the database, where you have to conform to a defined schema, or a data warehouse where you need to actually process that data through a formal ETL process before it's brought in. And this means you need to have a massive storage capacity. So because you're reading all this raw data in, it's not efficiently stored because you're just trading those random schemas on entry. You're not going through the refinement that a database or a data warehouse would. It needs to have a lot of storage space, but it also can be cheaper storage because it isn't structured. And so some of the use cases, and the reason why you want to do this is it's really an efficient way to, or it can be an efficient way to handle big data and real-time analytics, as well as machine learning and advanced analytics, because what you can do is you have processes, analytics and machine learning processes that say, hey, I know I'm going to look at this sector of this unstructured data. I know how I had to read it in such a way that I can interpret, information from it. So you define, kind of the pathways to massage whatever information you want to get out of that unstructured data. And then you're able to run those analytics processes on that and say, hey, just collect the most recent information about this data lake, transform it into a readable format, and then feed it into my analytics dashboard, or use it to continue to generate predictions or train a machine learning model. So let's say like every day you have a machine learning job that says, hey, collect today's customer transaction information, and then bring it into this machine learning process that because they need raw data for machine learning to then generate some predictions on, or use to train the model, whatever. And it's also good for data exploration and discovery. You have all of your data in one place. You can get a lot of different kind of cross discovery. So you can see, hey, how does this data relate to each other, ways you might not expect, because it's all in one place. And so some of the advantage of this, it's flexible. It can store a lot of diverse data types. So maybe you're a B2C application, and so you're collecting social media, email, you're managing all these external sources. With non-standard data types, data lake can be a great approach for you, because you also probably need to do a lot of analytics and machine learning on top of that data. And it's scalable and cost effective, because you're just storing raw data and you're only transforming it when needed. You're not constantly running processes to transform that information. So it can be cost effective if you manage it correctly. And that's because data lakes have a potential to turn into a data swamp really quickly. If you don't have processes, where you can actually look at that unstructured data, transform it into something that is structured, you're not really going to be able to get a lot of insights out of that data. So really recommend, if you're going to go for the data lake approach, don't just say, oh, I can just, have all this unstructured data that I can query whenever I want. Have a plan for how you're going to take each piece of unstructured data and turn it into something that's actually usable. So you need to have really strong governance here and metadata management, because you need to tag everything, make sure you know what everything is. When it's some IoT thing that's coming, it's just strings of like hexadecimal numbers. So got to be careful here. So just to kind of summarize everything, so you can have a little takeaway from this video, I got a handy dandy Google Doc together of just some of the main comparison points for each category. So in terms of data, database and data warehouse, it's going to be structured. You're going to have to define it to a certain format. You're only going to be able to consume certain types of data. Versus the data lake, you can really, think of it like Joey Chestnut. You can eat anything. You can put anything into it. You're just going to dump a ton of unstructured data in there. And so what the use cases this enables for the three of these is, hey, I'm able to, do kind of customer transaction processing, do banking transactions, manage anything that has a lot of in-out operations that's happening constantly. Things like inventory management, constantly things that need to be updated continuously, that are maybe action-based. Data warehouse, that's where it's, hey, I've got all this data. Now I want to use it for analytics, for ML, for downstream use cases, bringing it to other teams. And then similarly to a data lake, just different approaches to how, they enable these operations, but, using all that unstructured data for big data analytics, for machine learning, for exploring that raw data, for really deep predictions, and understanding kind of the raw data as it comes in from all those different sources. So it's a great way to amalgamate all. And then for processing type, so as I kind of explained, databases are really good for OLTP, online transaction processing, anything that's constantly happening. Data warehouses are designed optimized for OLAP, which is online analytical processing. And then data lake can do it all. It can do both OLT and OLAP. Scalability, databases, as I said, once you get to a certain size of data, that you kind of, lose the scalability. It just gets really hard to query and really hard to manage. Data warehouses are better for larger scale, but they require more infrastructure around it to actually support it. You need to have ETL processes because you need to, massage the data into certain formats before it can be stored. And then data lake, highly scalable because you can just keep slapping more and more unstructured storage on it. So it's really easy to scale that up. And so the cost for each of these, moderate for a database, it's really kind of just entry level. It's not free. It's pretty, costly. As anyone that's looked at their database bills and you see all those like, how much they're paying Datadog and things like that, or Snowflake and whatever, there's the 10K. Data warehouses, similarly, you need to build a lot of infrastructure around it. You got to pay for all that as well as the actual data warehouse. And then you're running queries and stuff, and all that costs money as well. And then for a data lake, pretty variable. It really is just it's directly correlated to the amount of data you're using. So if you're bringing in a lot of like 4K videos, it's going to be pretty pricey. But if you're just bringing in transaction information, it's not that pricey. So schema on write. So this is just a predefined schema. You must meet it for the database data warehouse. Data lake is schema on read, so it'll just take whatever is read in and generate a schema based on that. Data integration, it is typically a database is just one data set. Data warehouse will store data from many different sources. It'll have many different tables within it, and many different sub databases. And then data lake can ingest data from any raw source. Real-time processing. So databases do real-time processing. As I said, they're constantly bringing in transaction information. That's why they're using OLTP. Data warehouses are not doing real-time processing. They're doing batch. They're taking large amounts of data and querying that, and that can take minutes to hours in some cases. And then data lake can do it all again. It can do both real-time and batch processing depending on kind of the layers above your data lake that you build. And finally, complexity. Moderate for database. It's kind of the entry level to storing data past like S3 buckets. Data warehouses are, again, very high. You got to build ETL processes. You got to build things around a data warehouse. It's not just your data warehouse, and then that can be really large as well. And then, as you can probably imagine, the data lake is the most complex because you need to build a lot of different mechanisms on top of that raw data to actually organize it, govern it, and then finally actually use it to transform it into a usable format, or figure out a way to ingest it and use it for whatever your purpose is. So anyways, that is all I have for you today. So I really hope you enjoyed this video. If you did, please like and subscribe. If you didn't, let me know what you didn't like in the comments and what video you'd like to see instead. So anyways, that's all I got for you today. Data Guy out.